All right, it looks like we're ready to go. So let's get started. So good morning or afternoon, depending on where you are, to everyone. And welcome to today's webinar about modern network compliance, what it is and how to achieve it. As a quick intro, my name is Glenn. I'm the Director of Product Marketing here at Itential, and I am joined by our resident network expert, Rich Martin.
Hi, everyone. I'm Rich Martin, Senior Technical Marketing Engineer at Itential.
So we're excited to jump into today's topic of defining modern network compliance and how to achieve it through a modernized approach. But before we get started, let's discuss a couple of housekeeping points. So everyone on the call will be muted. If you have any questions along the way, just drop them in the questions panel, which you can find under the webinar. We'll do our best to answer questions along the way, but most likely what will happen is we'll wait till the end and answer during the Q&A session. And if we can't get to one of your questions, we will answer them via email shortly after the webinar. So let's get started. Of course, here's a picture of us in case you guys are wondering what we look like. So let's just run through the agenda really quickly. So first, we're going to talk about network compliance. We're going to define it. We're going to talk about the factors, both internal and external, that drive network compliance. We're going to talk about cloud services and how they have complicated achieving network compliance. Then we'll jump into Itentials' approach to modern network compliance. We'll talk about the components of modern network compliance as defined by Itential. And then we'll walk you through the journey toward achieving network compliance and talk about some of the advantages of using Itential's platform to help you achieve that. And then, of course, a Q&A session after that. All right. So network compliance. So Rich, talk to me about network compliance. What is network compliance, and what do we mean by that?
Yeah, this is a big term, so I think it helps to start with a clear definition, and not a definition that's like too complicated. Generally speaking, adherence to the network standards set by your organization. I think that's a great foundational starting point for understanding network compliance. We're going to have a set of standards. We've got to apply those standards to the network. And if you look at the standards and kind of how we define them, we want to pick three categories they tend to fall into. It would be security, reliability, and performance. From a security perspective, like security is top of mind. Every organization out there is totally focused on security, especially on the application, servers, things like that. But the reality is, generally speaking, security needs to be applied everywhere. Just a single device that's insecure causes huge problems, right? So think about networking as well. Network security, maybe in the past, hasn't been as top of mind, but it's certainly important, especially considering where the network is in the stack of ITs, organizations. It sits there and processes packets. And as network devices like routers and switches have gotten more and more sophisticated, some of them run like complete OS stacks like Linux for BSD. And this becomes really interesting to those that want to attack them because it gives them a vantage point. So this is critical. We need to make sure that security compliance, so basic rules, are set across the entire network. Reliability, I kind of joke, the ultimate test of a network's reliability is how often the phrase the network is down is uttered by the user. This immediately causes networking people to tense up and go into like fight or flight mode. But reliability is important as well. I mean, as a network practitioner for many years, I want to make sure maybe people who aren't aware of networking understand there's plenty of redundancy and reliability features and functionality built into networks today. At every level, there's like hardware reliability. So we have like the ability to fail over within a chassis or router or switch,
right,
something like that. Or you can deploy multiple routers in a network so that they fail over. There's all kinds of, protocol redundancy and redundancy links. But the key to reliability is that you have to have things configured correctly for them to work.
Indeed.
And if they're not configured correctly, the moment you need, so you can deploy all these things, and the moment you need, you configure them for reliability. But if something happens and they get misconfigured over time. The moment you need that reliability, that redundancy feature, it's not there.
Right.
And that's again, the network is down. So that's a big consideration. It's a big part of your network standard for your organization is reliability. Performance, from a performance perspective, it's very similar to reliability. When I think about networks and how we build networks, routers and switches traditionally, tons and tons of performance features. If the application is slow, who gets the blame? Come on, be honest. The first finger gets pointed at who?
The network guys.
The network, right? So we have in the world of networking, we have lots and lots of performance features and functionality from, load balancing, quality of service, traffic prioritization, traffic steering, like all these things exist to help us, build performance or steer traffic around problems. But again, all contingent upon the configurations working. And now we're not just talking about just one device. We're talking about multiple devices in the network that have to be configured for the right parameters for those features and functions to work. There's a story, if you'll indulge me for a minute, with IP telephony. So it's amazing how far it's come. I mean, think about what we're doing today, know? But when the early days of IP telephony, there were some performance issues because now you're driving voice over IP, voice over Ethernet, and voice over IP. And so there was some bandwidth issues. So there was the need to do some quality of service features within the routers and switches. But again, it's not just one switch. This is a feature that needs to be configured correctly across all of the routers and switches that traffic can traverse. And so what people were finding in the networking world was we can configure this, but as changes get made over the network, or if we add new devices in the network and we don't have a consistent configuration for this quality of service feature, then at some point that feature stops working. And so the performance aspects that we built in to this, unless we keep up with those configurations and making sure they're always up to date, eventually fails.
Yeah, that makes a lot of sense. So just to recap, when we're talking about network compliance, we're really talking about adherence to the standards that are set by the organization. And I think a lot of times this is a concept that gets confused with external regulation,
right?
And compliance to an external regulatory body. When in fact, that's probably one of the drivers that we'll cover on the next slide here that informs how an organization designs its network standards. So let's talk about, of course, these are three just examples here. And there are, of course, many, many more, and each is unique to an organization. But let's just talk about some of the drivers of compliance.
Yeah, this is a great thing to talk about, because when we use the word compliance, it comes with a lot of, it can mean different things to different groups in IT. One of the first things that always pops to mind is some sort of regulatory policy that must be adhered to, like HIPAA or PCI. They're well-defined, things for around data security and privacy and all these other aspects of the business. But what that actually means when it kind of trickles down to the network is that our devices need to have these very particular configurations on them in order for them to be compliant to that standard. So it kind of has to go through a translation layer. And on the networking world, it means, so for instance, things like, in PCI, it defines that certain parts of the network have to be completely separated from other parts of the network, right?
Right.
And so that means, well, what does that mean? Well, that means on the networking side, we need to have like two separate networks, or maybe VLANs, and only certain devices can be on this VLAN and only certain devices can be on this VLAN, and we have a secure way to connect them together. And if those things aren't configured correctly on all of your devices for that part of the network, then it's no longer in compliance. So that's one aspect that kind of always jumps to top of mind, especially with security. But that's not the only thing. And I think this is probably where networking teams understand compliance from the sense of, okay, I have to do these things because of external regulations. But then there's also this subset of rules and security compliance that they adhere to that they may not recognize as being part of a standard, right?
Right. These are just best practices.
This is just best practices, yeah. Right? Like, and over time they've adopted more and more and more of these things. So, for instance, most of the regulatory rules, do things that are pretty common sense. Like we should turn off unencrypted management of any of our devices,
Right.
right? But then there may be other things that have become best practices. Like, hey, when we deploy a switch, let's just turn down all the ports unless we need them. That way somebody can't come by and plug into them, right? That may not necessarily be part of a regulatory requirement, but that's like, hey, something we learned over time as networking folks that helps to secure the network. And unless that's put into like some sort of actual standard that's set in stone and we know these things exist, how can you be sure that's always being put into practice?
Right.
And again, from a security perspective, everything needs to have that level of security across the board, no matter what the device is.
So that's an external driver. Let's talk about some internal drivers. So, we talked a little bit about best practices, but, just reliability, running the business, those types of things too, also play a big part in defining those standards.
Yeah. Networking has always been about building reliability. I talked about some of the features and functionality, but in the modern world that we live in today, there's a lot of, processes and strategy around digital transformation. And it's putting more and more importance and scrutiny on the network itself, right? So now if there's an outage, it could be a catastrophe in the sense of like customers are actually down versus an outage that maybe a part of our internal network can't, our users internally can't operate. And so now that we're shifting a lot of this around digital transformation and those kind of strategies, we want to deliver faster and more services to our customers internally and externally. We have to have the most reliable networks possible. And again, networking teams have been building reliable networks, but as we all know, things can fail. Things will fail over time. There's this guy Murphy who likes to visit us quite a bit in the world of networking and IT.
I think he lives in my house.
He might indeed. But so devices will stop working. Power supplies fail. Apparently, there's a series of backhoes that do nothing but cut cable across the country.
It's a great job. Yeah, you can get it.
These things happen, and many of them are variables out of our control.
Right.
What we tend to find in networking, though, is that many outages, and who knows how many, but more often than we want to admit, occur maybe because of misconfigurations. Right. There is a failure of some sort. We have some reliability built in, but because of misconfigurations, the failover didn't happen.
Right.
Right. And so these are the kinds of issues. Like there's a whole set of issues that we can't control. So we build reliability in the network because of those things. But then far too often we run into issues where we can't control these things. And it was because not enough attention or process, or we didn't have the tools to validate configurations or verify configurations across our entire network to make sure they're always consistent, to make sure these features and functions work.
Yeah, it's interesting. You talk about digital transformation and how that is informing business strategy. And so, as you were talking about earlier, these reliability and performance being two sides of the same coin, these are the sorts of internal factors that really, I think, are important towards defining the standards that ultimately manifest in network configuration.
Yeah, absolutely. One of the big things that we've seen in the industry too is the ability for applications to scale up very, very quickly. I mean, cloud had a big part of that, but then also, other technologies. And the network needs to scale up as well.
Right. And
again, there are lots of technologies that network teams today are used to. They've deployed them, but it's more important than ever that the network doesn't impede this scale up process.
Right.
And so again, making sure that the configurations, wherever they are on any device in the network, these features are configured correctly so that those things that enable scale up performance are always ready to go and not in a state of misconfiguration or, out of sync with another device.
Yeah. Yeah. Well, I'm glad you mentioned cloud and application delivery from the cloud, because I think that's a nice segue into the next slide here.
A nice segue into chaos is what it looks like.
Right. And so I think, the notion for many years is that the cloud was really going to simplify things for IT in general. But what's really happened is that it's complicated the network significantly. So talk to us about this slide, what we're seeing here, and how cloud services, SaaS delivered products, things like that have complicated the network.
Yeah, there's a lot going on here for sure. if you kind of look at, if you can kind of defocus and look at just the green areas of this slide, this is what I would call the traditional network, data center, the enterprise looked like this. This was a very, I won't say easy, because, nothing in networks is necessarily easy, but as far as like control of where our applications were, they were in a data center. Right. And so there was a very specific place that these things were located, and we had a data center network that was built to scale out, these applications. And connecting to the data center, we had our headquarters or remote offices, and they may have come in on a different device or a different side of the network versus our internet connectivity, which came in from a different side. And it's almost like this little fortress. We built this little fortress network where we're protecting our applications, we're servicing, our users either from the internet, and we have really tight control, and we have a very good knowledge of how our traffic flows because of everything is kind of like in its place.
Well, and the fortress is a lot easier to enforce those network standards and network compliance than across these distributed networks and cloud and so on.
That's correct. And, so then what ended up happening is shifting applications into, say AWS is kind of a first start, is what most enterprises have done. And, AWS does a good job. All the cloud providers, do a good job of spinning up kind of the minimal networking that you need to bring up an application. But over time and at scale, you run into these limitations on the networking side. So imagine, within the AWS platform, your application teams hits this problem where we have too many VPCs, which is a networking structure, right, within the cloud, and how to connect all these things together. Maybe they're in different regions. How do we connect these things together? Because the way we used to do it doesn't work anymore. Well, now you have to have something called a transit gateway, and if you need to connect that back to on-prem, now you're talking a lot more complicated and complex network configuration using protocols like BGP. And that's just for one cloud provider, right? Enterprises are deploying across multiple clouds. Azure, GCP, a lot of niche clouds out there.
Right.
Different organizations, different teams are making the decision to deploy their applications there. And they're all part of an overall service or application. And so the connectivity between a cloud and the on-prem was one issue. But what about how do we connect all these different clouds together, applications in the cloud? So I've got VPCs here and VNets over here. How do we do that? It gets very complicated very fast. And then on top of that, just cloud native services like, for security and things around that are a piece of this as well. And so connecting all these things together becomes something that a cloud team is not capable of doing, because now you're really bringing into being, real hardcore networking things in the cloud that are like a lot more complicated, but these are their natural, when we talk BGP, that's a natural thing for a networking person to understand. They've been doing it for years.
Right.
And so now bringing the networking team into the world of the cloud, now they have a platform and a seat at the table, but they're being thrown all of this stuff, and all of the networking stuff in the different cloud platforms are very unique to each other.
Right.
They may not even operate the same. Sometimes they're called different things. Sometimes they have different features and functionalities, and it's been given over to the network team to say, hey, help us figure this out.
Right. So enforcing compliance standards across this type of network is increasingly complicated. But I think you really touched on something that's important here, which is this sort of organizational problem, right? Where you've got siloed teams, you've got cloud ops teams that are doing things that are networking without knowledge or without the networking team knowing that it's going on. And so it becomes even more difficult to enforce these types of configuration and compliance standards when you've got separate teams kind of working on the network in different places and doing different things.
Right on. Yeah, a lot of data is coming back showing that, there are some, at scale, enterprises are seeing a very, high rate of issues and experienced through security and compliance problems, right? And I think this is very interesting because from a networking practitioner in traditional networking world, compliance is an understood thing. Like we need to have this set of standards on different devices.
Sure.
But now in the cloud world, it's not really been top of mind. Automation has certainly been top of mind. How quickly can we spin these things up has been top of mind. But think about all of the networking services that have been spun up, and now a networking person has to go in and go, not only do I have to learn this new thing, right? But I have to go back and see it. Were these things configured correctly?
Right.
Because make no mistake, every network component in every cloud platform has a configuration of some sort. It may not be accessed and managed the same way as a traditional device, but it does have a configuration that needs to be ensured that it meets the standard. Again, go back to what we spoke to before, is every device on the network. And so it's irregardless of whether it's a physical, virtual, or a cloud service, needs to be in compliance.
Right.
So one of the issues is, okay, we've got a problem because things are being spun up. Networks, the network stuff is like out of control. We don't know how to hook these things up. So that actually means there's probably things that haven't been configured right previously. And now the networking team has to have a modern set of tools to help drive compliance across all of this complex cloud stuff.
Indeed. So if your network looks like the picture that we were showing before, and your organization is structured like this, which is not unusual at all, there's a really good chance that you've got some compliance issues.
I would gather yes, from speaking to customers and then looking at the data that's been coming in from different reports. Absolutely.
Yeah.
You can be assured that there are probably things out there that have not been configured correctly, even though they might work, but to a standard that gives us security, reliability, and performance.
Right. Indeed. So let's switch gears really quickly and talk about Itentials' 3 major components for modern network compliance. So Rich, just walk us through these and give us a little definition around each one.
Sure. So I think step one here is we need to think really, really, really hard at our ability to create and enforce a golden configuration. So going back to our definition of network compliance, adherence to a network standard for your organization. So this is the network standard part,
okay.
Right? And I think traditional tools have done a good job, right? But there are certainly some deficiencies in those, especially around all of this new modern networking stuff, this cloud stuff, right? And so we need to have the tools that can bridge that gap between both sides. So being able to define a golden configuration.
So before you go on, talk to me a little bit about a golden configuration.
Okay.
What do we mean by that?
So take our standard, right? So take our example of we have this network standard that's been driven through regulatory compliance, which means I have to turn off Telnet and SSH on my physical devices, and maybe I have to have some security policies that say only this subnet can manage this device and those kind of things. So we turn those into actual commands or CLI rules on devices, and that becomes part of our standard. Okay, so now we've got this template that needs to be applied to all of our devices, and again, all of our cloud stuff as well. And we need to make sure that's always consistent. There's a consistent application across all of these devices, because if something falls out of compliance, that becomes a security issue, then that's a big problem. So first you start off by defining these particular rules, right? Coming from all the different drivers. And that's what golden configurations are. And what's interesting about that is, when you look at a golden configuration, there's going to be a subset of commands that may be very globally applicable, right? To many, many, many devices. And there may be a subset of commands that are applicable to, core routers or, edge devices. And so having a golden configuration that's flexible enough for teams to be able to use and quickly make these configurations, these standards, but then apply them to many devices is key to this new modern way of doing things, as well as being able to do it in the cloud. Because what we've found as practitioners is that if these tools are very difficult to use, if I have to build a golden configuration for essentially every device in my network,
nothing's golden.
Nothing's golden, and we're just not going to do it. It takes up too much time.
Exactly, way too time consuming. Yeah. So in essence, a golden configuration is the manifestation of all of these standards in a set of rules that you can apply across all types of networking devices, including cloud and virtual networking devices.
Yeah, cloud, virtual controllers, anything that does networking functions.
Right.
That it has to be configured in order for it to work, and those configurations need to be checked to make sure they're under compliance to their standard.
Okay. So let's talk about automated remediation.
Yeah. So that's kind of the next step, right? Just because we define the standard that everything ought to be compliant to, we need to be able to check those devices, right? And then what happens when we find out that, because I would imagine as if this process hasn't been, in an enterprise hasn't been installed, you're going to find a lot of devices out of compliance.
Sure.
Right? What do you do at that point? If you've got a backlog of thousands and thousands of changes that need to be made,
you manually do this. Is that where you're going with this?
Yes. Yes.
One at a time. I'm going to go through every device and remediate.
And with networking teams already experiencing backlogs and kind of day-to-day operation and changes, this becomes a critical piece of things of function of their role that they have to get done. But man, this is a huge backlog.
Sure.
So as part of this, we need to have solutions and tools for modern compliance that helps us automate these things, the remediation, the fixing of the CLI configurations or API-based configurations that are out of compliance. When we detect these things, can we automate them? And we want to be really clear too, because networking teams, we're always under the scrutiny of something going down or, bad performance. And so there are a subset of, configurations that can be immediately remediated because perhaps they don't cause any kind of outage potential, right? But then there's a subset of things that maybe you want a little bit of human oversight. They click a button, they say, they look over it and they say, yep, that looks good. They click a button and it makes those changes, right? So that's another level of automating the remediation process. And then other things maybe that, are very sensitive. You want, human intervention for those things, right? And then over time, as your network becomes more compliant, right, and stays in compliance, automation becomes kind of more of a trusted, process.
Makes sense.
Yeah.
Makes sense. So let's talk about validating changes.
So this is a key component to a modern solution. And the reason why is this. When we say validation, what we're talking about is kind of like phone a friend, right? I need to ask somebody who knows the network, or something, somebody or something that has an intelligence over the network that says, if I make this change, will it bring me out of compliance? Ironically, this happens today already, but it's completely manual, right? There's a networking team and there's somebody making changes to the network and they will ask their buddy, hey, Glenn, the senior network engineer or the network architect, is it okay to make this change? And Glenn, you look over and go, no, are you kidding me? Why would you even think that? No, right? This is you're doing it completely wrong. That's what you would tell me, right? But no, that actually happens, right? I mean, but the thing is, can a human being keep up with all the network standards that must be applied, right? And this is an evolving, changing thing too. Like over time, we expect maybe more security rules to be put in place, those kind of things. So why not have a process that says anytime somebody is about to make a change, they're proposing a change to a network device or service, we run it through the same process that's doing our compliance checking to validate that this will not take us out of compliance. Because now what you're doing is a normal compliance check is very much if something is broken, as far as a compliance CLI rule or an API rule that takes something out of compliance, we have to detect it after it's kind of broken, right?
That's right.
And that's been generally the way it's always been done. But given all of the drivers and the importance of the network today, we need to implement validation so that we avoid doing anything that brings us out of compliance, right? And reduces risk of insecurity or, unreliability and, and taking things out of, making things less, performing less.
Right. So this is a proactive approach.
It is much more preventative and proactive approach, which totally makes sense. Like I said, network teams are doing this today. I've got to go I got to talk to Glenn, who is my network, and he's the guy, right? But again, once you can create that golden configuration, then you have kind of an engine that can do the checking. What we're just doing is just asking, hey, is this okay if we make this change? And now what the net result of that is, we take a network that's now in compliance and we continue to make sure it stays in compliance.
Right.
No
rogue changes are made.
Exactly.
Those types of things.
That's where that's where we need to head to in the industry for sure.
Gotcha. Okay. Well, let's talk really quickly about the journey toward network compliance as we define it here at Itentials. So Rich, if you would just kind of walk us through each of these steps and briefly tell us what we mean by each of them.
Sure. So, and this is probably, most of this is probably self-evident for anybody that's been a network practitioner for any amount of time. Whether they've defined it as nicely as we have here or not, but it comes from, background experience. For instance, you have to have an inventory of some sort. Like,
sure,
I have a bunch of routers and switches on the network. Where are they? What's their IP address? What's their name? Sometimes that is as sophisticated as a spreadsheet or a
most of the time
Google or shared Google spreadsheet, right? But something like that exists. Like you have to have that, right? And then from every one of those devices, how do we manage those configurations? At its simplest processes, can we make backups? There's nothing for a network engineer. A recent backup of a device is the ultimate insurance policy.
That's right.
And not a backup that like I took a year ago or when it was first deployed. And so having this backup, the set of backups, right, is important for every single device, because at some point, like we said, things are going to fail. And hopefully you have some resiliency and redundancy built in so it can handle the failure without taking an outage. But in the case,
replace that device.
But you got to replace that device. And if those other things don't work, and so if everything is hard down, then when the clock is ticking and I have to replace that device, I want a backup that has every single change that was made up until the point it was.
Yeah, it might be a little time consuming to rebuild that configuration by hand.
I won't.
Memory.
I would. Yeah, you're bringing up some real bad memories.
You got some PTSD from this.
Yes, indeed. So managing configs is a big piece of that, and then managing devices. I mean, one of the things that also goes along with this is we're talking about device configurations, but part of compliance is making sure the operating system, the network OS, or just the software and the firmware is up to date. Every network vendor is, updating their software so that it has more security, right? They're patching bugs out and things like that, security and bugs and putting in new features or, fixing things that might cause, it to act not reliably.
Right.
So it's always a good step to update those things as part of being compliant, right? So, and being able to manage, devices, pushing day 0 and day 1 device configurations to your devices as well. Create and enforce network standards, what we talked about. You need
configuration.
Yeah, you need to have a standardized list of what your, configurations are. So wherever sources those come from, they need to turn into network configuration that a networking person can take a look at, understand, and then apply to their devices. Auditing and compliance reporting. Network teams love data. We love data. We don't get enough data, but we love data, right? And so one of the things that we really need to provide for them is, in regards to this, is the ability to take a look at over time, what does that look like? How are we doing with our compliance? Are certain areas of the network dropping out of compliance? If so, why? And then being able to provide that data, for any kind of security audits or things like that, that may be part of that regulatory policy.
Exactly.
Yeah. And then change management. I mean, networking teams, as well as all IT teams nowadays, spend a lot of time in, ticket systems and ITSM systems. And so can we integrate what we're doing here with that? Because, I mean, that's not only a way to save time, but it's also another layer of preserving any of the changes that have happened on a particular device. And let me tell you, that might be really handy to have if something else fails in the network and you're trying to rebuild a configuration.
Right. Let's look at the change log.
Exactly. Exactly. And then again, finally, validation, right? So if the journey includes all of this, let's also include validation so that once we get to a state where the network is compliant, let's keep it that way.
Right.
Let's keep it that way.
Indeed. So that, of course, all makes sense, and I'm sure it makes sense to most of our listeners. Let's talk about Itentials' approach to each of these steps.
Sure. So what Itential does is, we focus on all of this because we are a modern solution to the network compliance and automation issues that networking teams have today. So we start off with that first step, inventory management. Let's get out of the spreadsheet world.
Right.
Let's have a federated device management. And what we mean by federated is we can connect to multiple sources. So we can connect to controllers. We can see individual devices that are CLI driven or controllers, like for SD-WAN, wireless, things like that. And then also network services in the cloud. So VPCs, VNets, things of that nature, and consolidate them into a view so that we federate that data, consolidate it into a view, and provide that as an inventory that our customers can look at and see in one place, and then build configurations across those for golden config. Around managing your configurations, being able to take those automated backups, both for CLI and API and virtual devices, and then once you have a set of backups for these devices, being able to have some handy tools like doing config, taking a look at the differences in configs. And if you need to make a change to a device, being able to do rollbacks.
Right.
It's not all network vendors support that, but using our platform, you can gain those capabilities across the board.
Okay.
Managing devices, we talked about software upgrades. This again is something that needs to be done consistently, and with all the devices and an organization's network, it becomes very hard to do that. So building an automated methodology that you can trust to do things like software upgrades. And of course, managing devices is also, managing the life cycle of their configuration and applying these, day 0, day 1 to day n, which includes standards that we've talked about, which takes us to creating enforced network standards. So the golden configuration standard that we talked about. What's really nice is that we've taken a look at some of the problems of creating a golden config for every device and said, hey, there's a better way to do this. Let's build this into a way that a network engineer can kind of break their configuration up to like the most global, set of configurations, and then apply that to, a bunch of devices. And then as we've kind of broken these standards into CLI, we translated them into CLI commands. These apply to this kind of device, and these apply to these kind of devices, and allow them in one view to create standards that cover many devices. And then because of that federated method of the way we do inventory, we can bring in network services that are cloud-based, because those aren't driven by CLI, command line interface. Those are driven by API, application programming interfaces, but they still have a configuration behind them. And so what we do is we allow you to create those same types of golden configuration standards across API solutions as well. So this is very unique, but this is also incredibly important for this modern network because more and more of it is being done in the cloud.
That's right.
Auditing and compliance reporting, again, making sure that there's a way to look at that historic reporting and scoring so that you know where you stand in your network across the board, and that you maintain a high level of compliance. And if not, hey, what's going on? Is Rich going in there and messing around with the configuration, causing it to go out of compliance? Well, being able to take a look at that and analyze that is important for networking teams too. Again, we have to have the highest level of uptime. So that means compliance across the board. So having that auditing and compliance reporting is important.
And then the automated remediation.
Absolutely. That's right. Automated remediation. Thank you for reminding me is a part of that as well, because the amount of, especially on the front end, the amount of changes that need to be done to bring a network into compliance across the board would be a big task. And so that our solution allows an enterprise to automate, to remediate those automate those changes to remediate these devices, and then do it in a way that allows you to have control over how much intervention or how little intervention that you want to have from the networking team. And again, meeting the customer where they're at with this in their automation journey. Change management. So like I said earlier, lots of teams spend lots of times opening tickets. What if during this process, because there's an integration into, say, ServiceNow, a lot of that can be done in an automated way as part of the process of checking configuration, finding out that things are out of configuration, doing the automatic remediation, but then at different parts of those steps, being able to open the ticket, update the ticket, close the ticket.
This seems like an area where a big time savings can be had.
Huge time savings. I think one of the things that most organizations that are kind of just getting started in compliance and automation, they don't realize is that there's a lot of time that can be saved, especially repetitive work on the network. If you can automate these things, like automate some of these changes, but there's a tremendous amount of time that's being spent in other systems, specifically like ServiceNow and other ITSM systems as part of that process. And so integrating to that into other systems as part of the whole process helps you to generate the maximum amount of benefit for your automations. And then finally, validation. This is kind of the bookend to this whole process, because we finally get to that state of network compliance. Do we want it to revert back? Of course not, right? And so we won't, but we also need to make sure that we don't, that we make sure that we preemptively validate our configuration changes so that we avoid any of those mistakes for even a minute. You know what I'm saying?
Right.
Like if I have to make a change to a device and the next compliance check doesn't roll until the next day, it'll fix it the next day, but for that 24-hour period, you might be exposed to something, and that might be enough. So there's got to be a better way, and that better way is called validation.
Right.
Making sure that particular change will be compliant to those standards before it's even made.
Okay, so that's all we've got for today. So we would encourage all of you listeners to try Itentials out. It's free to get started. And all of the benefits and features that Rich described are available to you to try out. So we encourage you to do that and see if this is a solution that will help you and your journey to network compliance. We do have a handful of questions in here, so I thought maybe we could just pick a couple of these, Rich, and walk through these while we've still got a few minutes here.
Certainly. Let's see. Okay. First one here is, how often should we be doing compliance checks on the network? Great question. There's not an answer. Like ultimately, as often as possible, but that's not necessarily feasible.
Right.
And maybe it's not necessary. I mean, because if you've got a configuration that hasn't been changed on a device in a while, then compliance check and a backup may not be necessarily needed immediately, right? But you want to make sure that you look very closely at the different areas of your network, because a compliant, like for instance, the core part of the network, right? The core routers of the network probably want to have a compliance check fairly often, whatever that needs to be, simply because where it is in the network is a very strategic and important place. Lots of traffic going through there. Maybe you have multiple interconnections, and maybe there's a lot of changes going on there, right? And so with a change, with constant changes that are going on there, especially if they're manual changes, there's an opportunity for misconfiguration, things like that. And so you want to have a compliance check done more often on that. And there could be other parts of the network where there's not as many changes,
right?
And so you still want to have a compliance check, but maybe not so often, right? So the real thing here, I think, that's driving to this question is, do we have a system in place that allows us the flexibility to define compliance checks for different parts of the network at different times because of their importance in the network? And then can we change that over time? And ultimately, this leads to validation, right? So instead of having to worry about making compliance checks at different intervals, I think you still need compliance checks at different intervals, but validation helps to ensure and enforce that things don't go out of compliance, so that you need more compliance checks.
Right.
So those two things go together. It's a great question. The solution needs to be able to address the ability to schedule over a certain amount of devices, but ultimately it's going to be that organization's decision based off of like, this part of the network's really important, and there's lots of changes going on here.
Right.
Doesn't cloud platforms already support some sort of network compliance features? Surprisingly, no. Surprisingly, no. They're very good at spinning things up very quickly, right? But once something is spun up, there's really no methodology for a process to go back and say, oh yeah, that's configured correctly. And by the way, who has access to your AWS dashboard, right? And do they have access, if they're an application person, do they have access to the networking parts of it?
Right.
And also keep in mind that a lot of cloud teams have done some networking. And so they're used to kind of going in and making changes. But now, how does the networking team that now is going in to help build and stitch all of these network services together, they have to go back and understand what was configured before. And so it's ironically, cloud has been about automation, very, very quick. How can we spin things up quick and tear things down quickly? But it also allows people to make changes. And there's really no concept of, okay, here's my template and, for configuration standard, my golden config. And if anything changes, then it alerts me or it says no. Like that doesn't actually occur. And it's surprising to a lot of people, because again, it's all about automation in the world of the cloud, but it's not necessarily about enforcing these things on the networking side.
Fair enough. Well, I think that's all the time we've got for questions today. We've got several more here in the queue. Rest assured, we will email you answers. But thanks again for listening in today. Before we go, I want to make sure that you guys sign up for the rest of the series here. We've got another one coming up on September 7th called Go Beyond CLIs and Adopt APIs, where Rich will talk in depth about that topic, and we may even have a guest speaker. So encourage you to listen in on that and to sign up for all of the rest of the webinars in this series. So thanks again for joining, and have a great day. And as I said earlier, if we haven't answered your question, we will get to you by email.